Hey YouTube, it's Dimitri, and today we're going to talk about Python. So this is probably going to be a very unpopular video, but I figured I would dive into this since somebody asked, and people have been wondering, and I've been quietly not saying anything, and I haven't made any Python videos. I've been wanting to make a lot more videos on technical things like R and SAS and Python in general, but I just haven't gotten around to doing it. It takes a lot more time and planning. But people have been asking, so my new job requires Python. Thumbs up, right? Use Python. But people have been asking, Dimitri, what do you think about Python though? You haven't really talked too much about Python, and I have not talked too much about Python because I don't have a lot of nice things to say about Python. And it's not that it's a bad language. So let's take a step back here because I know there's going to be Python fans jumping off buildings right now, metaphorically at least. I don't understand a lot of the language wars. Like I don't get like the Python versus R versus SAS versus MATLAB versus, I don't know, we could add in there Julia and Rust and C++ and a bunch of other languages. I just don't get it. Like I don't get why there's such a feud between them. I have preferences and I'll explain these preferences and why they work and why they don't work and what I think Python could be good for. But why I'm not a fan of Python in itself. So the number one thing I do not like about Python is the fact that it is open source. So this shocks everybody. Open source, Dimitri, it's great, it's wonderful, it's free. And just with free, you get exactly what you paid for. Free. There's not a lot of great things inside of Python. And what I mean by this is so let me take a step back onto the banking side here. So go back to my home base of banking. Banks use SAS. I love SAS. When I started my career, I hated SAS. And maybe this will be Python in the future. Maybe I'll hate Python today and I'll love it in the future. But the thing with SAS is banks use SAS because regulators like SAS. And the reason regulators like SAS is because SAS is comprised of thousands of employees that manage and maintain this language of SAS. And because they maintain that language, SAS basically guarantees, because you're paying money for this, right? It guarantees that the language is operating exactly to the mathematical notation. It's exactly what you would expect for the prediction. There is no ambiguity with it. There is no this package kind of works, but this one works better. And these two results don't even match, but yeah, they kind of match. Python or SAS in itself, it's, you get what you pay for. You're paying a lot of money for it, but you're paying for all those software engineers behind the scenes. And more specifically, which people I don't think realize, to do the software engineering is one piece of this. The second hard piece of the puzzle is finding a software engineer or a team that can work with statisticians and mathematicians to actually get the functions and the packages correct. Python, though, on the other hand, the advantage of Python is the open sourceness, which is more or less like it's free. You can download things. Anybody can write code and anybody can share code. But we start to end up back in this conundrum here of what I've been frustrated with the quant community, the data science community, the stats community, which is finding things online is just, it's annoying. Like things online are garbage. Most things that are free online are garbage. It's great that you can go online and you can learn to program in R and Python quickly and easily, and you can find a lot of resources. But most of it's just wrong. Like the stats, like time series, for example, is my specialty. So this is where I can really dive in. The majority of things done in time series, the majority of books by these publishers that promote open source and free and cheap alternatives to learning, unfortunately, that comes with a cost of it's just poor quality and much of what you're doing is incorrect. Now, if you're working in technology or somewhere else where you're predicting, I don't know, how to increase number of likes or something, you have some stake in it that the firm's investing money, but it's not like a bank or a financial institution where if that model doesn't work, you just lost millions of dollars, right? It's a lot. There's more on the line when you're wrong. It's more important to be correct and be robust than it is to be extremely accurate. And if it fails and blows up miserably, like in tech, it doesn't really matter. You can patch and put things together. And it's not a bad thing in tech. I'm not saying that tech is dumb and incompetent, though I think they have their issues along with banking and quant finance and everybody else. But their problems are just different. Like image recognition, NLP, all those things. It's nice to have something very accurate. It's nice to have something correct. But if your NLP or some sort of language prediction is not 100% correct, Doesn't really matter. Like, it's not like you're going to get sued. It's not like you're going to lose a bunch of money on it. Now, you could lose a bunch of customers. So don't get me wrong. There is money and consequences for not doing these things correctly. But there's just a lot more emphasis on the finance and banking side with this. So people want examples a lot of times on this issue. So I'll give an example here. There's been a lot of issues with Python in the statistical realm. So let me talk about statistics first here. So statistical wise, the main package in Python is going to be stats models. That's just what it is. You can go and find other sorts of things, but they don't produce a lot of the nice, pretty output. And this comes into the fact of training. So being a manager and someone that runs a team, often employees, new employees, even experienced employees that have been doing it wrong at other firms don't know all of the tables, all of the tests, everything to look at for building a model. And so from a manager perspective, it's really nice to have software where it's like they write the code, they build the model, and then out of that model comes everything you need. So for example, like logistic regression. The fact that you can run a logistic regression and your walled chi values aren't output next to it, or your VIF, like that's just annoying. And the problem with this is it's not that Python can't do it. Python can do it. It really can. But your employees now have to know to run all those different sets of code to pull out of that package or that function here, how to extract and pull out all these additional pieces of information that you might need in the view of Python developers. You don't might need them, you absolutely need them to make the correct decision. But again, it doesn't output them automatically. And so from a training perspective now, it costs more money for managers to train people. And often, unfortunately, a lot of the managers don't know what to look for. So the manager doesn't know what to look for. The package doesn't make a good recommendation. The employee doesn't know what to look for. And so you end up selecting models that just aren't good. And there are tools available, again, which would be free in Python, that just aren't being used because nobody really knows. So there's a training piece to that. Now, on the flip side of that, why SAS is so great and wonderful and why I like it, SAS outputs all these tables and all this information. So as a new employee, when I tell you go build, let's say a logistic regression here as we're talking about, and I say go build this model, it outputs all these tables and all these charts. So the coefficients, for example, automatically come out. And it has like your walled chi values, and it has your VIF, so your variance inflation factors. And it has a bunch of tables and charts that all come out of this. As a new employee, you're looking at that like, I wonder what this means. I wonder what this other value means. And so as an employee, you can have a better understanding of what to look for because it's all right in front of you on the screen. Now, also as a manager, when I say, hey, I need this value or I need this test, they just look back at their code and I tell them, hey, it's on the output. Just go look at your, proc logistic output here. And they'll go in there and they'll grab the output, copy and paste the table. I can explain the table and we can all move on very quickly. Now, in Python, it's not that simple. It's not that straightforward. And so there's a big training cost with it. There's also this annoyance of having to use multiple packages to do all kinds of things. And unfortunately, there are multiple versions of multiple packages that all do the same thing. But more specifically, the results don't always match. And the question is why? Often it can be hard to find the answer to that because sometimes the documentation is not very clear. Again, with SAS, why you're paying for that is because they provide very detailed documentation because they're literally paying employees to do that and to keep up all these essentially functions, you can call them packages, but all this built in SAS, very, very well documented with good academic sources here. Now, another example here on the Python side is weight of evidence. So you cannot build a scorecard, or at least you should not be building scorecards, credit scorecards here in finance without using weight of evidence. The simple process of why this is important is it bends things into different categories based on your dependent or your target variable here. And it gives what's called a weight of evidence calculation. The calculation itself is extremely simple to do. If I remember correctly, it is like the natural log of the number of goods divided by the number of bads in a proportion to that bin over the total count of goods and bads that you have in the model. And anyways, that creates what's called weight of evidence. Now, you can Google and go online for Python and find it. And I've found a few packages that do it. And I've had employees that are using different sets of codes. But we all end up with different results because the way that these packages bin out the data. Now, the problem with this, again, is now I have to go back through and validate these packages to make sure that the package is what it's doing, how it's doing it, and how we get to it. And again, when you learn how to do weight of evidence online, so if you run out there and Google how to do weight of evidence, it seems extremely simple because It is pretty simple, right? The calculation to do weight of evidence is very simple. Then you can take weight of evidence and get what's called your information values, so your IVs. And that, again, is another simple equation, and you can automate this. The issue now with Python, in this one example, there are many to come, which I'm not going to provide in this video, but these are the issues I'm struggling with. The algorithms to actually separate and bin out these bins here, the areas that we're trying to calculate weight of evidence for, are done quite stupidly. So weight of evidence, it should be based on groupings here. So not to get into this too much, but most of these algorithms create bins that are essentially in deciles or in equal binning. So there's an equal number of observations in each bin. And so it goes through and it bins all these out, and it checks the bins, and then it looks at a few different values, and then it combines them, checks them again, combines them, checks them again. So basically you end up with typically some of these algorithms, you're ending up with equal bins. If you look at, again, a lot of the free information on how to do weight of evidence, this is how they tell you to do it. This isn't necessarily wrong. It's just your models aren't going to be very good because the weight of evidence binning is done quite poorly. If you think about a variable now, a univariate, so just one variable, just a number line, and you stack all the values on this number line for a variable, you're typically going to end up with clustering. Now, imagine that number line, imagine there's all kinds of different clusters on there, and I want to get the variables in the closest bin together in groupings. Now, if you divide them into 10 equal bins, and then you go, okay, well, that wasn't the best, so then you group them into 9 equal bins, and you check that, and then you go into 8 equal bins. Numbers don't work this way in the real world. They don't equally space themselves out into bins, and so often you're splitting an actual cluster. And so in one bin, say you have 10 bins, you split the cluster such that you have all of the values in one bin for one cluster, so you have awesome binning. But now you have a few other clusters that are getting cut into different fractions and parts. So then you reduce the binning or increase the binning to capture this. The problem is the bins aren't going to be evenly spaced, the values on these bins. I need bins that are focused around the actual freaking clusters here, and this just drives me nuts. So now you have me writing, again, my own weight of evidence package in the background. I'm supposed to be building a model which has a deadline and we have to hurry and get it done. And now Python doesn't have a good solution to do that. So now what I'm having to do, so to give you the inside dirty secrets on what I actually have to do in practice, is find one of these really crappy binning tools, bin out as much as I can with a lot of really small, fine binning, so lots of bins. Then I put it into Excel, and then I have to hand bin these to get the correct bins and the correct monotonic relationships based on the target variable. Now, again, SAS doesn't even do a stellar job at this, but it does a similar approach, which is kind of frustrating. But often in the industry, we have specialty tools built out for this. So in this case, both SAS and Python have not done well. There have been other areas, though, in time series, for example, on the way, for example, that tables are constructed for ADF testing, which again, if you screw up the ADF testing and it's not done correctly, the rest of all of your output, no matter what you do, is going to be garbage. Again, Python has not done a stellar job at that. And I've used multiple packages for ADF testing. So again, it just comes down to this ease of use here. And now for some criticisms here on SAS and why you would use Python perhaps more. Python has been developed, a lot of these free packages, by a lot of the big tech firms, and they are gung-ho on data science and machine learning, and that is awesome. SAS, on the other hand, since they have to have so many personnel and staff to make these packages and do them exactly correct, to the exact solution, and it has to be optimized and ran just perfectly, they are very, very, very slow at creating new packages. Since Python is open source, just like R, you have a whole community of people and you can have clusters of people working on packages, and packages come out much faster. And because the tech industry has decided to build out a lot of their own tools, which is what we end up having to do on the fintech side here now at my firm, they're building their own tools. They've provided these free to everybody. And so again, their machine learning and data science things are much faster and easier on the open source side. Now, the other frustration with SAS in itself is SAS is now chasing auto ML and auto nonsense, and it's trying to make a lot of its programs and a lot of its language point and click. The point and click versions of SAS are garbage. Point and click of any software is garbage for model development. They all suck. They all have the same problems. You don't have enough control over the different variables and fine-tuning process. You can't really understand the information that you're trying to model. So SAS EG, Enterprise Guide, the original one, is awesome. There's a new one like SAS EG or something on the cloud. We briefly used it at one of the banks. I hated it. It was just crap. Like, just build machine learning the same way you built the statistical packages and just put them into the original SAS and make it good. But for machine learning and data science, SAS is absolutely terrible, at least when I used it here a few years ago. So again, in a firm, if you want to run things optimally, I would prefer to use SAS for all of my statistical modeling, testing, and all that. I would prefer to use Python or R more specifically because it's more academic, and a lot of the packages I trust more so because a lot of them are built by universities and academic institutions, so I have slightly more trust in R. But again, using an open source package to do machine learning and data science is a better option. Any real quant fund should, in my opinion, at least be using both. SAS is expensive up front, but it's quick and easy to train employees. It's really easy to get people going, and the results are going to be correct. Again, you can screw up and not use it correctly, not read the results correctly, but SAS provides everything under the sun. It is fast, it is easy. You're not out building your own packages just for the sake of building packages. Python, again, it's free, it's easy, it's terrible at statistics. I have to build out a lot of these packages by hand because what we have in Python currently is just fragmented pieces of some things kind of work. Again, I'm guessing most people using Python who are using all the open source stuff either don't know how to do statistics correctly because they haven't ran into this issue. Or I could think like a lot of firms I've actually been talking to, they said, yeah, we love Python. It's great. It's wonderful. And I'm like, well, how do you get around these issues? They go, oh, we have all of our own internal packages that we build to fix all this and add all these, kind of patches and bugs. And then just to top all this off, because people think I am a crazy person for talking bad about Python, Marco Lopez de Prado's book is even a good example of this. And he's the one using Python in the book. So this is the book here, Advances in Financial Machine Learning here. There are sections in the book too. He mentions like this package works great, but there's a bug here, and here, and here's some awesome code to fix and patch that. Now, again, if I was paying for Python like I paid for SAS, I would expect it to just be fixed and done and correct. And that's what SAS does. They drop everything and put a bunch of employees on it, which costs a bunch of money. With Python, though, you have open source. And so with that, you have a bunch of issues and bugs. And again, if you don't know those issues and bugs exist, so you don't go through and read all the package documentation, you just don't know. And even if you do that, again, it just costs more in time and effort. So in my opinion, use SAS for stats. You're not wasting a lot of time checking, rechecking, reading documentation, and fixing all these issues with the code. For data science, machine learning, again, Python and R are better. I wish SAS would just step up and do an awesome machine learning package all built into Enterprise Guide. I don't know why they haven't done it, or at least I have not seen it. I would love to see that. But again, I just wish there was more, quality to open source. But I guess that defies the whole purpose of open source, is it's free, it's easy to use. And not knocking on any of the developers that are doing the software and the packages here. There are some great, amazing packages out there. But often those that spend all their time building packages typically aren't people in the industry that are actually having to use the package. So there's always going to be a disconnect between them. And again, if they're not being paid by anybody to build the packages, there's not as much of an incentive as an employee at a firm who's being paid to fix these issues. So that's kind of my take with Python and SAS. And again, I wish Python was like this dream and it solved all of my problems. But often too in Python, with part of this frustration is you have to write out a lot more code to do something simple. So as a final point here, I think Python in itself is too simple of a language and too complex of a language all at the same time. And what I mean by this is that in Python, you can do almost anything because it's just a basic programming language, which is awesome. So it's very low level in that sense. But then on the other end of it, there's like all these packages that make everything super, super simple. So it's like a really high level language. And the issue is, from a practitioner standpoint, is often I want something in the middle. I think SAS actually fits that better. There's aren't packages per se that are like so rigid and dialed into only this exact unique problem. But again, SAS is only having to do stats. That's basically what they've been doing for years. So it doesn't have the flexibility. It doesn't do all these awesome, cool things that Python can do. So Python's more flexible and open. But again, I think Python is too rigid in a lot of the implementations and too black boxy in the way that a lot of the packages are done, which is more the developer's fault of these packages. But also the language is too dumbed down to the sense, and it's too low level where I'm having to write way too much code to get the same simple thing out. Where things like SAS, again, time is money. So I wouldn't expect someone to build, I don't know, a statistical model in C++ or C because it would take them too freaking long to do it, even though you could do it. It's too much extra knowledge. It's too much time programming. I think Python falls into that realm a lot of times where it just takes me too much coding to get there, where in SAS, I can build models faster and more efficiently. And at the end of the day, I'd rather pay my employees to do the technical, challenging part of model development instead of doing the software engineering. Let's rebuild a bunch of packages, or let's write out 10 times as much code to get the same solution. So anyways, those are my 2 cents on Python versus SAS here, versus R. I threw R in there a little bit as well. But anyways, thanks for listening. Thanks for watching. And as always, until next time.